Acid catalyzed hydrolysis of an ester is where we take an ester, then using a strong acid like sulfuric acid and water, and then we convert it into an acid. Now you may be thinking, hey, this just looks like the same conditions as a Fischer esterification. And that's because it is. Now, if you remember from our Fischer esterification video, I said all those steps are actually in equilibrium, and the Fischer esterification is reversible. So it reverses. If we had a Fischer esterification, we're going this way with an alcohol. This is the acid catalyzed hydrolysis. We're going this way. This is essentially the reverse of the Fischer esterification. So if you know that mechanism, this is going to seem really familiar to you. And if you need to know that mechanism, go check out my video on it. So what's the first thing that happened? Similar to the Fischer esterification, we protonate this carbonyl. Now I'm just going to use H plus here for right now. If you don't know where H plus comes from or why this is just kind of used for shorthand, that's fine, but it's generally used to just denote generic acidic conditions because, space is at a premium. You don't want to be writing it all over, but know that you can't just buy a bottle of H plus somewhere. So we're going to protonate that. We're going to form this right here, where we have a positively charged oxygen in that carbonyl, which it's not happy about. So we're going to kick some electrons up there while also attacking with our water. Actually, that water is going to attack first and then kick those electrons up. I got a little ahead of myself. I got excited. Then, next thing that happens is we have a tetrahedral intermediate right here, where we have an alcohol. We have what was part of the ester. Now we have H2O plus. Now, this part, depending on your professor, you may not need to know as much. You can just say, you might just be able to say proton transfer. You might have to show water coming in, taking this, and then giving it back to here. I don't know what you need to do. Only you do. Only your professor can tell you that. Because I'm just going to say, for this step, I'm going to say H transfer for me. Okay? I can't. That's what I'm going to do. But if you need to, on your exam, show water coming in here, taking this, and then protonating that right back, make sure you do that so you get all those points. Just ask your professor, okay? So we have a proton transfer in here. And now we have an OH. Now we have essentially an alcohol plus on here. Well, what's going to happen? We're going to come back down, recreate our carbonyl. We're going to kick this off because now it's a decent leaving group. And we're going to come right back up here. And we have a protonated carbonyl again. And that just cannot stand. So we're going to have water come in. This time I will show we're going to water come in, take that proton, kick these electrons back on. We're going to form our acetic acid, in this case, our acid. And then when you take this last proton, that's your reforming your acid catalyst, which is your H plus. Or you can sometimes, they might show it as H3O plus. Just you know what your professor likes to see, okay? Then also in this, you would have generated an alcohol plus. In this case, you would have generated ethanol. And then that's why I say this is the exact same conditions for Fischer esterification, because now we have an alcohol, we have an acid, we have sulfuric acid. Come on, this is, if you do it in reverse, that's your Fischer esterification. So remember, this hydrolysis with this acid catalyzed is reversible. So this really isn't your ideal way, because you're going to have a mix of products. And what you might need to do is really heat this high to evaporate off any alcohol to really push this to the productive direction that you want. And there is another way to hydrolyze acids. It's called base catalyzed hydrolysis, and there will be a video on that. It should be coming shortly. Go give that a check out. And make sure you hit that follow button if you want more organic chemistry content.